morning, Year 10. Going to do something a little bit different this morning. I'm actually going to give you a starter like I do in a normal lesson. So what you could do is you could find a piece of paper, write these questions down quickly. Once you've done that, you could pause the presentation, have a go at the questions, and then restart the presentation when I will be going through the answers on the board for you. So just in case things are unclear, evaluate. 12 plus 3 times 2 equals 6 plus bracket 8 minus 4 squared equals, factorise 8x plus 16, factorise x squared plus 8x plus 12. Calculate 2 cubed, calculate square root of 3 squared plus 4 squared. Simplify a plus 2a, simplify a multiplied by a multiplied by a. Solve 4x plus 10 equals 22. Solve 4x plus 6 equals 2x plus 24. Calculate the value of x, the value of this angle inside this triangle. If you'd like to write those questions down now, then you can pause the video, have a go at those questions, and then when you restart, I'll be putting the solutions on for you. Okay, solutions. 12 plus 3 times 2. These problems are both big maths problems that you should recognise. Order of operations is important. We covered this last week in our revision lessons. First operation we've got to do is the multiplication. 3 times 2, which is 6. 12 plus the 6 gives us a solution of 18. Again, big maths. Big maths says brackets first. 8 minus 4. 8 minus 4 gives us 4 inside the bracket. 4 squared, indices. 4 squared gives us 16. 6 plus 16 gives us an overall result, a solution of 22. Factorise. It's about putting things into brackets, putting these expressions into brackets. 8x plus 16, what is common to both of those terms? There is an 8 common to both of those terms. So our bracket will have an x inside and a plus 2. We multiplied that bracket out again, it would take us back to 8x plus 16. Factorise. It's a quadratic expression. If we factorise it, we put it into 2 brackets. We can put an x at the front of each bracket, and then we consider 2 numbers that multiply together to make 12, but when you add them together they make a positive 8. So those 2 numbers are going to be plus 6 and plus 2. 2 times 6 gives me 12, 6 plus 2 gives me 8. Calculate 2 cubed. 2 cubed is 2 times 2 times 2. 2 times 2 is 4. 2 times 4 gives me a solution of 8. 3 squared plus 4 squared inside the square root sign. 3 squared is 9. 4 squared is 16. Still inside the square root sign, the 9 add the 16 gives me a square root of 25. So my solution, the square root of 25, is going to be 5. Simplify. A plus 2a. They're like terms. They can be combined. We've got 1a plus another a plus 2a, 4a altogether. A multiplied by a gives me a solution of a cubed. Solving. 4x plus 10 equals 22. Balancing each side of the equation. We can do to the left hand side the same as we do to the right hand side. We're not changing the value of the equation. We want to get the x on its own. Subtract 10 from both sides. Subtract 10 from both sides gives me 4x equals 12. Now if we divide both sides by 4, that leaves me my x on its own, which is what we were aiming for. Divide the right hand side by 4 gives me a result of 3, x equals 3. 4 times 3 is 12, 12 plus 10 does equal 22, so it checks out. Variables on both sides, we've got x's on both sides now. Subtract 2x from both sides, doing the same thing to the left as we do to the right, gives me 2x plus 6 equals 24. We want to get the x on its own. Subtract 6 from both sides. 2x equals 18. Divide both sides by 2, gives me x on its own equals 9. And the final question of the starter, calculate the value of the angle x. What type of... No, it's not the end of the lesson, you've got to carry on, sorry about that. What type of triangle is this? It's an isosceles triangle because it's got 2 equal sides. If it's got 2 equal sides, it means it's got 2 equal angles. Those equal angles are at the base of each of the equal sides. So if this angle is 65 degrees, it means that this angle's also got to be 65 degrees. 65 degrees and 65 degrees, add those together, gives us 130 degrees. We've got a triangle here which has got 180 degrees, so 180 degrees minus 130 degrees gives us the fact that x is going to be 50 degrees. So that's our starter completed. We're now going to go on to the main section of the lesson. My trusty cameraman, here I am again. Circumference and area of circles is going to be the main topic for the lesson today. For most of you this will be revision, but it will allow us to move on during the week into slightly more complicated examples. Circumference and area of circles. We need to make sure that you can remember some terms relating to circles. The line that goes from one side of a circle to the other through the centre point is known as the diameter. So that's the diameter of the circle. The line that goes from the centre point to any point on the circumference, so from the centre point to any point on the circumference, is the radius. So 2 important terms. The diameter, the line that goes from one side of the circle to the other through the centre point. The radius goes from the centre point out to the circumference, the perimeter of the circle, so the outside of the circle. That's the circumference, is the special word for the perimeter of a circle. Other points to remember, or other terms to remember: a line that touches the edge of a circle. This is one for you to remember this. A line that touches the edge of a circle is called a tangent. If we take a slice of a circle like we have here, the slice of a circle is known as a sector. So that's a sector there. Okay, they're just some terms that you really should have in your head if you can, and we'll go through various other terms to do with circles over the coming days. Okay, really this is what I want to focus on today: calculating the circumference and the area of a circle. Again, for most of you this should be a revision. It shouldn't be too complicated for you. A reminder for most, and helpful to all, hopefully. Pi. Pi is a number that you should be aware of. You've heard it talked about, written out as pi, and that's the symbol that indicates pi. it's a number 3.141, and it keeps going infinitesimally as a decimal. So it just keeps going and going and going. The most I've ever heard anyone recite pi to was 100 decimal places, which a girl in a year 9 was able to do one lunchtime. Got a £25 Amazon voucher for doing that. 100 places, decimal places for pi. You'll add that value of pi on your calculators. Sometimes in calculations though, they ask you to take a value of pi that allows you to more readily use it in calculations. Sometimes that can be 3.14, sometimes it can be 3.1, and sometimes, as I'm going to do today when I'm doing calculations for you, the value of pi to be taken could be 3. The formula that we need to know. The first formula that we need to know, the area of a circle is pi r squared. If you've got pen and paper, you might want to take a note of that so you've got that written down, the calculations that you're going to be asked to do later on today. Area, pi r squared. Circumference. Now remembering that the line all the way across the circle is known as the diameter, d. The line from the centre point to any point on the circumference is known as the radius, it's known as r. The circumference, the formula for the circumference of a circle, there's two different forms of it. You can either say pi d, so pi multiplied by d, or you can say 2 pi r. Because the diameter is 2 lots of the radius. Got a radius here, so the diameter is the same as 2 lots of the radius. So hence you can have the formula in the form of pi d, or you can have 2 pi r. How do we actually use this, or use these formulae? That's an opportunity for you to make a note of the formula that you need. If we take a value of pi of 3, so I'm just going to say pi is going to be 3. The area of this circle, pi r squared is my formula. I said we're going to take a value of pi of 3. The radius is 5. 5 squared is 25. 3 lots of 25 gives me a solution of 75 centimetres squared. Don't forget the squared. Get your units right. The area of that circle is 75 centimetres squared. Now the circumference, we said one of the ways that we could write the formula for that is 2 pi r. So 2 times 3 times the radius. So 2 times 3 gives us 6. 6 times 5 gives us 30 centimetres for the circumference. Circumference being that special word for the perimeter of a circle. Simple calculation, just a reminder. What happens if we've got a shape like that? It's a half circle, it's a semicircle. So effectively, that 12 centimetres going from side to side is our value for D. So the diameter is 12 centimetres. The diameter is 12 centimetres. What does that mean? The radius is equal to? The radius is equal to 5 centimetres. That would be for a whole circle there. So if I'm calculating the area of that shape, the area of the whole circle would be pi r squared. This is a half circle. This is a half circle. All we do is that. That would be the area of the whole circle. Because that's a half circle, we just divide that by 2. So in this particular example, pi is 3, r squared, and we said, oh, I've made a mistake there, haven't I? The radius is actually going to be 6 centimetres there. The radius is 6 centimetres. That wasn't very good. The radius is 6 centimetres because it is half of the diameter. So 3 times r squared is 36. Divide all that by 2 will give me my solution. 3 times 36 gives me 108. That's only because I practiced that calculation. 3 times 36 is 108. Divided by 2 gives me 54 centimetres squared. So that would be my area. Pi r squared for the whole circle, the area of the whole circle, divided by 2, and that gives me my solution, 54 centimetres squared. Now, one further thing I'm going to show you, I'm just going to get rid of the calculation here. A question could ask you this, they could ask you the perimeter of that shape. The perimeter of that shape. Now notice that I've changed from using that word circumference to using the word perimeter. The perimeter of that shape is going to be the length of this curved section added to this straight section. Now that curved section, this is a semicircle, it's a half circle. So what did we say the circumference of a whole circle is? Pi d. Okay, so the length of this curved line is pi d divided by 2. The whole circle, the circumference, the perimeter of the whole circle would be pi d. So to get half of it, we just do pi d divided by 2. But then for the perimeter of that whole shape, including this 12 centimetres, we've got to add 12. So our perimeter for the whole shape is 3 times the diameter, which is 3 times 12, divided by 2, and then add 12. So what does that give us in total? 3 times 12 is 36. 36 divided by 2 gives us 18 plus 12. 18 plus 12 gives us 30 centimetres for the perimeter of the whole shape. So the perimeter of the whole shape is that curved length plus the straight length. Okay, that's the end of the lesson for the day. There is some tasks on SAM learning for you. They're fairly simple and straightforward tasks on SAM learning, and there are some worksheets. We will be making progress through the week. Some more complicated questions around circles or involving circles. Just one last little thing for you to consider, moving on from our last presentation. Just consider this. What well-known phrase or expression is that going to represent? Just pausing to give you a chance to think about that. You can pause the presentation if you like while you think about that. The answer, underline. You've underlined something, okay? It's actually a well-known phrase or expression. Hope that's been helpful. Don't forget SAN learning tasks which your teachers can monitor for you to complete. They're fairly simple and straightforward, and then there are some worksheets for you to work through as appropriate. Thank you very much for your attention.